Hello, welcome back to Statistics and Mathematics YouTube channel. Please kindly subscribe to my channel. Today I'm going to continue our discussion on questions and answers on geometric distribution. If you haven't watched the mathematics behind the geometric distribution, I mean the PMF, the mean, variance, moment generating function, and the characteristics function of geometric distribution, please kindly go back and watch it before you will start on the questions and answers on geometric distribution for you to really better your understanding on these particular questions. Okay, so question 1 says probability of male birth is equal to 0.51, female birth is equal to 0.49. A couple continues having children until they have one daughter. Find the probability that they have 5 children. So this is just giving you a clue that the couple continue having children until they have their first daughter. They have their first success. That is the geometric distribution question. So it says find the probability that they have 5 children. Okay, so here since we are talking about daughter until they have their first daughter, we are going to use the probability for the female birth, which will give us what probability to be what 0.49. That will be what the success. Okay, and then probability here, the question says you should find probability that our x is equal to 5. That is here, probability that our x is equal to 5. But we have our PMF to be equal to what? P times 1 minus p all raised to the power x minus 1, because we observe the number of trial until we got our first what success. Okay, so here we are just going to substitute our p and then our x into what the PMF to get what our answer. Once we substitute p is what 0.49, and the 1 minus p will give us 0.51, all raised to the power x minus 1, which will give us 5 minus 1, that is what 4. Once you point this on the calculator, we are getting our final answer to be what 0. We are getting our final answer, okay, to be sorry, we are getting our final answer to be what 0.033149. okay, so this is what our final answer. Okay, yes. And then our second question says each call to a radio station has a probability of 0.02 of connecting. Calls are independent. Find the probability that the first call that connects is the 10th call. Okay, so this is illustrating what a geometric distribution, right? The 10th call until the first call being what connected. Okay, yes. So geometric distribution, our p was given in the question to what 0.02, and our q would be 0.98. That's 1 minus p, which will give us 0.98. okay, and then our geometric distribution PMF is what p times 1 minus p all raised to the power x minus 1, or we know that 1 minus p is what q, so it can be used interchangeably. Okay, yes. And then our p2 was given as what, sorry, our x is given as what 10. There was what a 10 call before we got our first success. Okay, so here we are going to get 0.02 times 0.98 raised to the power what 9, because here we are going to get our p to be what 0.02 1 minus 0.02 all raised to the power what 10 minus 1, of which you are going to get 0.02 times 0.98 all raised to the power 9. And once you point this on the calculator, we are getting our final answer to be 0.016675. okay, so that is what we are getting. And then our question 3, this question 3 says that the moment generating function, given a moment generating function 3 e raised to the power t divided by 4 minus e raised to the power t, right? We should find probability that our x is equal to 1, probability that our x is greater than 2, probability that our x is less than or equal to what 4. First, before we can solve this particular question, we have to identify the moment generating function, the distribution that this moment generating function follows, before we can do that. So for us to be able to identify the distribution, right, we have to just simplify what the distribution as you can see here, right? This distribution as you can see here, right, the denominator can be written in this form because we are just moving 4 out. When you move 4 out, you are going to get 1 here, you are going to get negative 1 over 4, so that when you multiply, you are going to get this expression, right? So that's the reason why we had this one here. And then the numerator will be 3 times e raised to the power t. Okay, and then this one can be written as 3 over 4 times e raised to the power t, all divided by 1 minus 1 over 4 e raised to the power t. And then this expression more or less resemble what? A geometric distribution. Okay, because we can compare this to what? P e raised to the power t 1 divided by 1 minus q e raised to the power t. Okay, where we say that our p is equal to 3 divided by 4, and then our q is equal to 1 divided by 4. Right, so right now we have been able to deduce our p and then our q. Once you have been able to do that, then it means we are good to go. Okay, it means we can solve the question. It said we should find the probability that our x is equal to 1. Okay, probability that our x is equal to 1, right, is equal to what? P. Why are we saying that? Because we are going to get p 1 minus p raised to the power x minus 1. Okay, already our x is 1, so we are going to get p 1 minus p raised to the power 1 minus 1. Any number raised to the power 0 is what? 1. So we are going to get here to what? P. So our p here will be what? 0.75. That is the reason why we had probability that our x equal to 1 to be what? P, which is 0.75. Okay, and the probability that our x is greater than 2. Probability that our x is greater than 2 is equal to, we can write this one in the form of 1 minus p bracket open x is less than or equal to 2, which will give us 1 minus bracket open probability that our x is equal to 1 plus probability that our x is equal to 2. Okay, and already we know probability that our x is equal to 1 to be 0.75. What will be probability that our x is equal to 2? It's going to be p times what? Q. Why did we go p times q? To be that because we are going to get p 1 minus p raised to the power x minus 1, and our x is equal to 2, so we are going to get p bracket open 1 minus p 2 minus 1, which will give us p 1 minus what? P, and the 1 minus p is equal to what? Q, which will give us p q. That's the reason why we had this one here. Once you multiply, we are going to get 0.1875. We are going to add 0.715 plus 0.1875 to get our answer to be what? 0.9375. But here we have to subtract it from 1 to get probability that our x is greater than 2, of which our answer will be what? This one. Okay, and then question C says we should calculate the probability that our x is less than or equal to 4. So x is less than or equal to 4. That means that already we have probability that our x is equal to 0, probability that our x is equal to 1, probability that our x is equal to 2. So you have to calculate for probability that our x is equal to 3 and probability that our x is equal to 4, and then just add it, because you know that probability that our x is less than 4 is less than or equal to 4 is probability that our x is equal to 1 plus probability that our x is equal to 2 plus probability that our x is equal to 3 plus probability that our x is equal to what? 4. We are not starting from 0, because we have to hit a particular target. Okay, that's the reason why we are not starting from 0. Okay, yes, but for other distribution usually we start from 0. Okay, yeah, so just have to take that one in mind. Yes, so for that one we had this one, and then for the 4 we had this one, so we are just going to add this one. We are going to get 0.9969375. Okay, yes, so I'm going to leave this question 4 to you as what? An assignment. Please kindly solve this question and then share your answer at the comment section. Right, so we are just proving, right, we are just going to prove that the whole of this one is equal to what? This one, right, if our x is greater than x. Okay, so I'll check once you solve it and send your results. I'll check and then give you thumbs up. Okay, question 5 says an oil prospector draws holes where the probability of success per trial is 0.25. Okay, said probability that the fifth, we should find the probability that the fifth hole draw is the first productive ball. This is a geometric distribution question, so probability for that hole will be what? 0.25. Now you have been asked to calculate probability that our x equal to 5, of which here we are going to get p bracket to p 1 minus p all raised to the power n minus 1, sorry, x minus 1, of which you are going to get 0.25 bracket open 1 minus 0.25 all raised to the power 5 minus 1, and then we are getting this expansion, and then our final answer here will be 0.079101565. Yeah, that will be our final answer. And then this last question is tricky. Yes, said probability that the prospector fails to find a productive for in at most 8 walls, right? It means that once you fail, it means that the failure means no success in all the 8 walls. Okay, so it means that for us to get at most means that our x is less than or equal to what? 8, which is what? A failure. So for us to get a success, it must be what? The opposite of this one. The opposite of this one. And the opposite of this one will give us probability that our x is greater than what? 8. And then we also just learned that if we have probability that our x is greater than s is equal to what? Q raised to the power x. So that is the same thing we are going to do here. Okay, that is the same thing we are going to do here. Already we know that our probability of success p is what? 0.28. So if our x is greater than 8, it means that we are going to get probability that our x is greater than 8 will be equal to q raised to the power 8. And our q2 is what? 0.75 raised to the power 8. And that is what we have here. And our final answer will be given as 0.100113. Thank you for reading this following and then reading this particular handout, right? Please kindly subscribe to Statistics and Mathematics YouTube channel. Okay, now next video we are going to discuss what is termed as the negative binomial distribution. Bye, have a lovely day.